Hey everybody, this is Mr. Walsh, and I'm going over the stations review activity for the Unit 1 test. And so let's get started here. So for this, for question number 1, we're asking for accuracy and precision, and there's 4 different questions. Okay, and so for each of them, we should determine some sort of accuracy and precision. Okay, so here we go. Let's see. It's hard to see on the screen, but there's 4 dots in there right here in the middle. So this is both accurate and precise. Okay, here they're up top. So this is not accurate. I'm going to abbreviate accurate ACC so I don't have to write it all out. But they are precise. Okay. Now here, 1, 2, 3, 4. So this is, again, it's accurate, but this is not precise. Okay, and you're not going to see this anywhere on the test, but I copied this from the notes actually. Okay, and so if you get this, okay, now the 4 dots are over here. So this is not accurate and not precise. Okay. What is a quantitative observation? This is one that has numbers. Okay, this is an observation with numbers in it. Okay, and so you look around the room, give 2 qualitative observations about it. So qualitative has to do with properties, so this has to do with words. So this could be anything. It could be, the room is brown, the chairs are uncomfortable, the lab benches are black, whatever, as long as it's not a number. Okay, and then the last one here is counting the number of squares. Okay, and so she counted 126 squares. So when we do this is the measured value. Okay, so again, your job is to know the difference between the measured value and the accepted value. So this is the accepted value. Okay, so now we use this formula and we plug in. So we get 126 minus 156, the absolute value of that, divided by 156 times 100. So now that goes to negative 30, the absolute value of negative 30 over 156 times 100, which then is 30 over 156 times 100, if I can get it in there. And then this is 19.2%. Okay? Okay, so that was station 1. Station 2, it says name 2 base units. Well, the 5 that are on the sheet that you have, let's see, we have, let me make sure I write this. You have meter, mole, Kelvin, second, and I'm going to miss out, and the last one is kilogram. Okay, then this is very similar to the question on the quiz. Okay, it says the derived units. Well, second and kilogram are on the list of base units, so that means that these 3 are derived. Okay, and so now we do some conversions. I can guarantee you're going to see conversions, and so we now need to go from centimeters to meters. So in order to do this, let's see. So we have the prefix sheet here. So we're going from centi up to here. So this is -2 to 0. So we're going up. So we move the decimal this way. So we move the decimal point over 2 spots to the Beyonce. So that's 0.382 meters. Okay. And so this is now liters to milliliters. That's 0 to -3. So that's going to go down. So we're going to move the decimal point 3 spots. That's 3 places to the right. So that's going to be 1, 2, 3. We have to create some zeros in there. 73800. And that's going to be milliliters. Okay. And now milligrams in kilograms. So this is milli is -3. Kilogram is 3. Okay. So the difference is 6. Okay. And we're going from kilo. We're going from kilo here all down this way. So we're still going, we're going to move the decimal to the right 6 spots. So 1, 2, 3, 4, 5, 6. So we're going to get 25 million milligrams. Okay? Okay, station 3. This is measuring. Okay? We measured we measured all sorts of liquids in the graduated cylinder. So let's see here. This, it looks like to me that this is just below. So this is going to be, let's see, 25. That's 24. So this is actually going to be 23.9. Now, if you said that that's 24, you have to include the 0.0. Because remember, you always want to go one space, a little technical glitch. So one space beyond. You always want to go one space beyond. Okay, so now for this one, you can see this is a little above this line. Okay, so this is 2.5 now. 2.6. So it's 2.6 something. So it's going to be 2.65. So if you have to give me this, but if you said 2.64 or 2.67, somewhere in there, 2.63, whatever. But you have to give me this space. Okay, so same thing now. We have, let's see, this is 6.5, this is 6.6, so it looks to be right on the 6.6 line. So again, you have to give me one space beyond what's given, so that's going to give me a 0 here. Okay, now if you said that that's 6.59 or 6.61, I'm okay with that. But if you gave me 6.6, you have to put the 0 there because it's one place beyond what's given. That's the key. Okay, now this one's a little darker, so it's a little harder to see, but we're going to do this. And so this is 2.5, and it's just a little beyond 2.5, so I have 2.54-ish centimeters. Okay, now, you know, again, if you wanted to put 2.5 to 2.57, I'm okay with that. And then the last one here, this looks like something in the lab. Okay, notice it only gives you 1, 2, so we know it's 1 point something, and so we're going to estimate where this is, so we're going to say that this is 1.3. Okay, it says a block was measured in the lab, have a length of 3.23 centimeters, a width of 4.91 centimeters, and a height of 1.82 centimeters. It says, and so we want to find the volume in part A. So we have to do length times width times height, length times width times height. So 3.23 times 4.91 times 1.82, and we will come up with an answer to that. When I round it to the nearest tenth, I get 28.9, and that's centimeters cubed. And then we have to find the density of the block. So this is exactly like the lab where we would do, find the volume of the block and then do this. Okay, so we have the volume, the mass here. Okay, I guess there should be a unit there. But remember, density, the formula is over here. Density is mass over volume. Mass over volume. Density, remember, breaks your heart. Okay, looks like a little heart here. Okay, and so the mass is 190.6 0.5. The volume is 28.9, and we do that math. We get 6.6 grams per cubic centimeter. So we have element, compound, homogeneous mixture, or heterogeneous mixture. Okay, I'm going to abbreviate these E, C, Ho, He. Okay, so pure water, that's a compound. Hydrogen, that's an element. Sand, that is, you can see the parts to it, so that's going to be a He. Sugar water, you can't see the parts to it, so that's a Ho. Carbon dioxide, that's CO2. There's capital letters here, so that's going to be a compound. Air, that's a mixture, but there you can't see the parts, so that's a HO. A hamburger, you can see the parts to, so that's going to be an HE. Salad, yum. You can see the parts to it, so again, that's going to be HE. Okay, gold on the periodic table, so that's going to be an element. Italian salad dressing, if you're not familiar, you can see the parts. Okay, oil, water, they don't mix, and then you can see all the little things in there, so that's going to be a heterogeneous mixture, and a He. Iron's on the periodic table, and so iron on the periodic table, that's an element. And here's a formula. Look, a lot of capital letters here. So with the capital letters, you know that that's a compound. Gasoline. Gasoline is, so another technical glitch here. So gasoline, like I was saying, you can't see the parts, so it's a homogeneous mixture. And milk, same thing, you can't see the parts, so that's a homogeneous mixture. Okay, so now lots of stuff here. So this is chemical versus physical. Okay, chemical versus physical. If it's chemical, it's talking about how something changes. If it's physical, it's just describing things in words. So if something burns or is flammable, that's chemical. Density, the lab we did, that is physical. Length is physical. So silver can tarnish, and so that's going to be a chemical change. And then a tree rots. Rotting is a chemical change, or a chemical property. Mass is a physical property. Copper conducting electricity. Okay, when copper conducts electricity, it doesn't change what it is. It stays copper. Imagine if it's conducting electricity and it changed. Okay, your whole house would be not made of copper wiring. So that's a physical property. When something is corrosive, that means that it changes the stuff that it's coming in contact with. Clear, a color. Not that clear is a color, it's kind of how transparent something is. So clear, that is a physical. Fragile, physical. Burning is chemical. Again, a color is physical. Smell is physical. And a taste is also physical. Okay, so I give you all sorts of things that students have a hard time remembering. Any phase changes are physical, and dissolving is physical. Okay, cooking, digestion, rotting, always chemical. Okay, so let's take a look. Okay, exploding fireworks, that's chemical. Cooking an egg, that's chemical. Melting ice, that's a phase change that we just did up here. Okay, so that's physical. Dissolving, that's up here too, so that's physical. Burning, chemical. Rotting again is chemical. Digestion, okay, that is chemical. When something is ripped, that's chemical. That's physical. I got ahead of myself there. Okay, ripped is definitely physical. Lo siento. Okay, melting butter. Okay, that's a phase change, so that is physical. Cooking, burning is a form of cooking. It's bad cooking, but it's still cooking, so that's chemical. Cutting something, physical. Decaying, something breaking down or decomposing, is chemical. Freezing, that's a state change, so that's physical. Okay. Cooking or baking, that's chemical. Dissolving is physical. Eating something, okay. Eating implies digesting too, so that's chemical. Cooking, whether it's grilled or baked or whatever, that's chemical. And a state change, sublime, that's going to be physical. So last but not least, the kinetic molecular theory of matter. Okay, what is that? Okay, the KMT has to do with two things. Matter is made up of molecules. Sometimes we call them atoms. Sometimes we call them particles. But whatever, they're small parts of matter, and they are always in motion. And actually, temperature is a measure of how fast things are moving. Okay, so there are 6 phase changes, okay, related to how fast things are moving. As they move faster or slower, things undergo phase changes. So we're going to start here with, there's freezing, and then there is boiling. Sometimes this is called evaporation. Okay, and then there's melting, okay, which is kind of freezing and melting go together. Boiling, evaporation goes with condensing. And kind of the one that we don't ever think about is sublimation or subliming, where things go from a solid directly to a gas, and the opposite of that is deposition. Okay, depositing. Okay, so the particles in the 3 phases of matter. Okay, we have a solid. In this case, the particles are close together, moving slow compared to their other phases. Okay, a liquid, the particles are farther apart and kind of moving faster. Okay, and then in a gas, the particles are, way far apart. That's what makes a gas, and they are moving the fastest compared to their other states. Okay, so that's good. So now we do this. Okay, so we fill this chart in. So a solid, the volume is constant. In a volume, the particle speed is slow. The distance between the particles is small. Okay, so when the shape is variable here for the state of matter, we know that that's a gas. Okay, and the volume is variable. It can change with a gas. You can compress a gas. Okay, particle speed is fast. That's what we just described up here. And the distance between the particles is large. Okay, and everything that's medium or in between here, that's a liquid. And liquid has a constant volume, but has a variable shape. Liquids take the shape of their containers. Okay, so there you have it. That is the review sheet